Hi guys, welcome back to my channel. Right, in this video we're going to start learning how to write programs in C language. I'm going to try to guide you from writing simple program like the common hello world to a more complex difficult programs as we traverse in your LX system engineering program. Okay, the first task you'll be ever given to try is the hello world 0x00.c project. And then if you go down to these resources, you have C program here, a PDF file, which I am encouraging you to read through, though some concepts may not be friendly to beginners, but I think it's worth reading it, okay? And then try to watch this video, try to see this video. It's gonna give you more insight. Julian does justice to this Hello World program right here. And then coupled with this video I'm putting up to you, I think you're going to be better off than someone like me and some of us out there. Okay. Now, for this project, you're given this 4 basic command lines to use: GCC, printf, put, and putchar. I'm going to take my time to explain the applications of how to use this, the flaws, when to use it, what you need to do while using it, hence to gain understanding of how to solve your task ahead. Now, the first thing here is GCC. What is GCC? GCC is actually a compiler that you take your C program, compile it into an object code, and then translate it into a machine code, which the computer understands, and then give you an executable file that you can run the program when you call upon the file, executable file that you create through the GCC. Okay. Now, basically, there are 4 stages. There are 4 things the GCC actually does when you run it. The first thing is called pre-processing. Okay, let's just man the GCC and try to see to that. Let's man GCC from my sandbox. Okay. Now, if you look at the description here, it says when you invoke GCC, it normally does 1, pre-processing. So what's pre-processing? Now, preparation is actually in this way. Now, take for instance, when we actually write a program, which I'm going to do it right now, you would notice that there's what they call comments, and then the comments are some words that is used to describe or track a process or track the content of your program, of your code. Let's take for instance, I want to send a user an information or a message to give me a value. Then inside the program, I can choose to use a comment that says enter value, but not pay writing the program, just a comment. So when you actually run your GCC, the GCC will try to extract all those comments from running alongside your expected executable file. Okay. And another thing about the pre-processing is that there's what they call pre-processor directive, which is actually a directive to a file or a library. Okay, so the pre-processing will actually look into all those libraries and then bring it together to the content of your work. Try to associate the function you call in regards or in respect to the library. Compilation is a stage whereby your GCC relate all the codes you've written together, different functions, different places, relate them together, relates them in one, let's say one form, and then create an assembly code. Create an assembly code, which is now the what? Assembler. From here, the assembler will now take the assembly code and then create an object code. All right. Where the linker will now take the responsibility of linking all your processes to actually give you an executable code, something that will enable you to run the program. So those are the 4 stages that your GCC actually go through when compiling your code. But now, why do we really need this compilation? Let's go out of here and let's look at the reality of life. Let's see this programming language as human language. Take for instance, from a state or a country that you don't understand my language. For instance, if I want to say something like "Good morning," I can say "Mesiere Abadie Idioko." I'm sure you don't understand what I'm saying if you're not from Akwa Ibom, Nigeria. And now, what comes to your mind is, I really want to hear what this man is saying. What do you need to do? You need to bring an interpreter. Okay? In programming aspect, we call it a translator. A translator is a middleman that stands between the end um, language, which is what I am writing, the code I'm writing, and then is an intermediary between the code I'm writing to the machine itself. Because the machine doesn't understand what you're writing. At the same time, you would not understand the machine code. So you need a translator that will interpret your code to the machine. And then when the machine processes it, it will also interpret what the machine says to you. Now, you see that? So a translator can either be interpreter or can be a compiler. Now, what do you mean by interpreter? There are some programming language like Python that interprets its codes in lines. Let's say you have a code that has about 5 to 10 lines or thereabouts. Then it will take responsibility of interpreting those codes in line. Where there is error, it will pause and ask you to correct that error before it continues. But in a program like C, C++, JavaScript, it compiles everything at the same time and then gives you a flag of error if there's an error, or processes the your program. So having said that, there are some drawbacks in terms of the interpreted language, and there are some drawbacks in terms of the compilated languages. It's something that you can maybe make research to find out yourself. There are lots to cover up on that. There are a lot of introductions if you're actually new that you need to understand while we are in the process. But then I believe that you'll understand as we progress. So that's about GCC. Now, there are levels of GCC that we can actually use. We can actually try to see the code that is written in assembly language, try to see the compiled language output, try to see the object code. There are lots we can do on that. Let's see how to really work on that now. But before we do that, we need to take in the next stage into consideration, the printf. Okay, we will use this to illustrate the GCC. Now let's write a little program, just a low wall program, so that I can use that to explain further the use of GCC. Now first we need to create a file. Let's create a file called touch. Let's call this first program.c. Your file must have a .c extension. That tells your OS that you're trying to write a C file program, or a C file code, or a C file document, anything you want to call. If it ends with something like HTML, it simply tells that you want to write an HTML program. So your extension must always end with .c. Okay, enter. Now let's Emacs into that file. Now in here, I want to write my first program called Hello World. The first thing we'll do is to define your preprocessor directive. It's always something like this: hash include stdio.h. Okay, now what does this mean? The hash include is a preprocessor directive. The stdio.h means standard input output header file. This is actually a library. And let's bring this out to reality. If you go to schools or libraries in schools, you realize that they have different shells, right? And different shells stands for different departments. Let's say we have Department of Computer Engineering, have Department of Mass Communication, you have Department of Science Lab Technology, and the rest. Now, you cannot bring something like journalism textbook to engineering, because they don't have that relationship with computer engineering, at least at a certain level. If I want to read on journalism, I will simply go to Mass Comm, because that's their core field, and that's where you're supposed to find that kind of textbook. All right. So we have different libraries. Example, if I want to write something that has to do with maths, like square root, cosine rules, and on the rest of them, I need the matched header file, which contains of programs, functions that are written to execute mathematical concepts. All right. Example, I want to write 2 power 4. Now I want to use POW, which is the power function to write that kind of program. I will need the math.h header file. Okay. Now, in almost all your program, you will definitely be seeing stdio.h because it contains the standard input-output function. When you type something on the keyboard, example, this is keyboard, okay? Now, this is from the standard input, so it is the responsibility of the standard IO header file to understand what I'm trying to do. That I'm trying to send input from the keyboard, okay? If you maybe like a prompt the user to like enter password, enter name, you've been writing, you've been having some programs like that, let's say like Facebook or something, you're asked to enter a username or something. Now it's requesting you to put something, to write something, right? And that value you're typing will be taken from the what standard input. Okay. So now the process of telling you enter something, that is what output is, sending an output, expecting an input. So those are what standard input and output concepts. And it is defined in this header file called stdio.h. All right, we have a lot of libraries which we'll explore later. All right. Now, after the header file, the next thing you're supposed to do is to write your comment, but we're not going to do that for now because of Betty. We're not going to do that for now. We're going to do it in the next, probably as we progress in the video. This is just an introduction. Okay, the next thing here is to declare your main entry. It's called integer main. Now, integer main, what does this mean? This is actually where your program starts. The first is the preprocessor directive. The second is where you have the integer main is where your program actually starts, and then it is enclosed in a block. A block is just a curly bracket, something like this. And then all your code will be within this space here. That's where your code will reside. Let me just delete this for now. Okay. Now I want to print the common thing like hello world. So I'm going to say print printf, the F stands for the function, and then hello world. Okay. The quotation mark here informs the compiler that, oh, I'm trying to pass a string. This represents a string. If I don't put this quotation mark, it symbolizes a variable. You're going to learn that later. Okay, when you're done with this, you have to terminate your line. In C language and C++, you must always terminate the line at the end of whatever you're doing. So there are some exceptions to that rule, for instance, like if statements, like for, and even the integer here, the declaration of your function, you need to put the semicolon, all right? But every other thing needs a semicolon to be used to terminate that line. Okay, when you're done with that, the next thing you want to do is to return 0. When you return 0, you are simply telling the computer or the compiler that, oh, my program runs without error. It runs successfully. When the program returns 0, it signifies that your program runs without an error. But whereas there is an error alongside, it will not return 0, rather it will return a value which will in turn give you an error message according to what has been saved in the error no header file, which we will discuss that later. It's not right now. Okay, so I think we are set for the first simple program hello world. You can now save this file and exit from the Emacs. Let me clear my screen again and then try to let's see the content of what we have. So you can see here our first program.c, it's right there. But we cannot execute this file because we've not compiled it. That is where the GCC, remember this? That's where the GCC comes in. The GCC will now execute, or sorry, compile this file and give you an executable output depending on what you're compiling it with. Okay. Now I told you the processes it involves for this very program to execute. Now we use something like include stdio. All right. But when we run this program, it is not going to print that stdio. That is pre-processing stage. When we say gcc and then the file name, let's just call the file name.c. Now this is compilation stage. It's compiling the program to give you what? An executable output. Okay. If I run this program, if I run that gcc and then list, you can see that we have a.out. That is an executable file. Of course, you can see the color change. Now, if I say ./a.out, I'm trying to run the compiled file. So it's going to give me hello world. You can see it right here. And let's go back to add our new line so that it will separate the file from our root directory. Let's do that quickly. emacs first program.c, enter. Then we go to line 5 and then correct this /n, just add /n, and you can now save and exit. Now notice that we have edited something, all right? But if we actually run this program now, a.out again, it's still gonna give us the same result. Why? We have not compiled. You have to recompile your work each time there is any change. So I have to compile again, gcc, and then press this, enter. If I run the program again, a.out, you can see you have a low wall and a separate line. That's what you're trying to achieve. Okay. Now I may want to run my program. I want to run this to see the assembly code it generates. Okay. And I'm going to use the flag -s. I'm going to say gcc -S and then the file name firstprogram.c, enter. If you list, you will see something like firstprogram.s. Okay, so if I cut firstprogram.s, enter. Now you can see some things that you may not understand if you don't know how to use a write program in assembly language. If you know how to write program in assembly language, you definitely understand these. I know assembly language have 3 sections. I don't want to go into that, but this is how assembly language of the same program, hello world, that's common hello world you wrote. This is the equivalent program for the hello world. You can see how complex it can look. Okay, so this is actually a a low level language, very, very low. Now, some people sometimes say that C language is a low level language, but it's not actually true. C program is a high level language, no doubt, but why it is considered low level language is because C language allows you or gives you this privilege to be able to associate or relate with the computer core hardware resources, like allocating memory dynamically, like standard input operations, like some kind of things. It allows to relate to computer hardware resources other than other programs that like Python and the rest. I don't think they have that kind of privileges, like C does. That's why C is seen as, not per se it is, but it is seen as a low-level language. And besides, C is one of the most difficult programs to write. Python is easy. For instance, the same hello world I just wrote in C language with about, I think that was about 4 or 5 lines. In Python, just one line, print hello world. Simple, it will print. Okay, but okay, you now compare that to the the assembly language that we have all these just because we want to print hello world. So that's just the different stages of these programming languages and the rest. Okay, let's play this. Okay, now the next thing I will want to talk about that compiler, it's that the GCC is that you can actually run this. You can run your GCC with a different output name, something like this. GCC and then the file name .c. Then I will give it to I'm gonna call my output to be hello. Okay, enter. Now if I want to run this file, instead of using ./a.out, okay, I can use hello, enter. It's still gonna print my hello world. But what is the meaning of a.out? Okay, so a.out is actually the default name given to a compiled file. Now, take for instance, if I run gcc first program.c without this -0 hello, it's going to give me the default name a.out. But if I don't want it to bear that name a.out, I can now use -0 flag to create my own file name that it will bear, my executable file name. I hope that is clear. So a.out is the same thing as this hello. The difference is only that a.out is a default value if we don't specify the name. I think I've been able to describe what GCC does and how it works. Okay, the printf. What is printf? Printf is actually used to print a statement, to print results, to print, just like the name implies, print right to the screen. That's the basic use of print statement. Now, the print actually comes with what they call format specifier. Okay, format specifiers. Format specifiers are used to identify the type of value that will be printed to the screen. Example, if I want to print numbers, if I want to print letters, if I want to print characters, if I want to print strings, if I want to print floating point numbers, and any data that I want to print, you must specify what you want to print. Okay, now let's try to work on that. Emacs, let's still use our first program.c. Sorry, I think I have network issue. Let me restart my network. Let me just refresh this and then cd into our C training program. Okay, let's see the list. Okay, we have this here, and okay, I wanted to show you what print or format specifier means. So let's Emacs into the first program.c, right? And now let's say I want to declare a variable called integer number. Okay, and then let me call it equal to 10 or any number you like. Okay, now I want to print this very number here. Okay, I cannot just write something like this. Let's see. I cannot write something like this, num. If I run this program, it's going to give me error because I have not specified the format I'm trying to print. Okay, so hence I have to tell the compiler that I want to print %d. Now that simply means that what I am trying to print is actually, so having used this value, the %d, it stands for real numbers, digits. Okay, we have the %f to stand for float. That's to say, if I should apply f here, it simply means that I can print numbers that is of, let's say, 10.2, 10.3, 10.5, and all that, you know, a decimal kind of number. And if I should use s simply means I want to print strings as a latest character that is more than one. If I use c, it means I want to print just a single character. All right, so we have different, we have p, we have z, we have lu, we have different sort of format specifiers which I'm going to learn in the course of this video or because of this training as we are going. So let's leave it at the d first. Then I would want the program to give me a new line when I'm done with printing the number. So that's for the /n. So let's just save this. And then first, of course, you know, you got to recompile that again. If you don't recompile, it's not going to give you the right answer. So I have to GCC again. And the file name .c. Then I'm going to give it out to hello again. So let's try to run that hello, and then what you're seeing here is 10, which stands for the numeric value. Okay, so that's about printf at a fundamental stage. We're still going to talk more on printf. Let's go to the next one here, puts, P-U-T-S. What is puts? Okay, puts actually works just like the printf. Okay, but puts do not have a format specifier. Let's see how to apply puts. Okay, so I'm still going to use the same program to run that. Emacs, let me clear the screen first. Emacs. Let me open that file.c. Then I'll go to line 6. And from there, I'm going to change this from printf to puts. Now, puts do not have to, you don't have to tell the format specifier on puts. You don't use format specifiers on put, you just put it like that. So let's save that and print. Let's see what happens. GCC again, let's compile. This.c to hello. Oh, all right. So here we have actually run into an error, and then it's telling us that it's expected, the function expected a character data type, but what we're actually passing is an integer, which is not acceptable by puts. When you're writing programs, you expect such errors, multiple errors of this kind. It's not a problem. What matters here is how you can interpret the error message you have, and to debug your code. It's not a bad thing. It's actually good that you experience errors, so you learn them more. So let's see how to really work on that. Now, if you want to use puts, okay, let's go into the file again, emacs.c. Okay, so now puts cannot be used with integer data type, but you can use something like char data type. Let's say I want to print name, okay, and this is an array, so I can choose to say, let me just print something like ALX school, okay, and then right here I'm going to pass the name into this argument name. All right, let's save this and run that again. First compile gcc.c and then oh hello. If I run this program now, you can see that it's printed LX school. All right, that's very cool. So that's how to apply puts in the in your C program. Okay. So the next one here is putchar. Putchar. Let's see how to use putchar. But what is putchar? Putchar is actually a function that takes just or that prints just one character at a time. Let's say if you have an array of characters, you have to look through it to be able to print everything at the same time. But if you want to print just one character, it's very possible that you print that. Let's see how to apply it. So let's use the same file, emacs, then the file name.c. Okay, so let's change this to putchar. Okay, the put as the actually stands for string. So here we can have putchar, which stands for characters. Now, if you write just name, just like what you've seen here, it's not going to print. Rather, it's going to return error because you're trying to pass a parameter that is not accepted in the function. Let's try to see if that works. Let's clear the screen first, and then GCC the same file name. Outputs will be the name hello. Now you can see that it's expecting an integer data type, but what you passed to the parameter was a string. So hence we're not supposed to pass such into a putchar function. So what are you supposed to do with that? Let's see to that. emacs.c. So right here, if you want to pass a parameter using putchar, what you will do is to specify the index at which you want to print. For instance, the ALX school here takes index from 0. The A is 0, the L is 1, the X is 2. Now, if I want to print the A, I'm going to put this 0, that's index of 0. Now, I'm not actually passing the character by string type, but I'm passing an index, which is an integer data type, that will in turn print the value that stands in the index of the array. So if I should print this, if I should compile this, now you can see it's compiled, and if I try to run this program, what I'll have on the screen is just A. Okay, now the A is right here, and then we didn't have a new line. That's why we have it written alongside with the home directory. So let's see how to create a new line using putchar. Emacs and this.c, we cannot actually use a new line alongside with the putchar. We can't do that. But what you can simply do is to write another putchar and then define a new line with a single quote. That means a single character. If you're using double quotes, it means it's a string. So single quote stands for a single character. Okay. So if I GCC now and then run the program, you can see that the A is printed on a separate line. So that is the work of putchar. Now we've actually completed the four major tools or commands you're supposed to use for this program. So let's go hit straight to the tasks ahead. The first one here is preprocessor. Write a script that runs a C file to the preprocessor and save the result into another file. The C file name will be saved in the variable C file. That means you've been given the C file or the variable name where the C file is being saved, and then the output should be saved in the file C. So what that simply means is that you should compile your file and then send it to the C file. Let's say that's going to be GCC. You can choose to use the flag -e, and then the file name was given as what's the $C file. So we have this C file, and then the output, you take it to C, and then you can run that. That's going to work for you. Remember that you're supposed to write those things into your shebang. That's your bash kind of the scripting program. You're going to write that as a script, and after that you're going to grant your permission by using the chmod u plus x and then the file name, which is given as 0 preprocessor. And of course at the after creating your repository on your GitHub, you need to create a readme file and then create this new directory 00 hello world, and also create another readme file before stepping onto these solutions. Otherwise it's not going to check your code. Okay, take that into consideration. Number 2 here, it says write a script that compiles a C file but does not link. Now the C file name will be saved in the variable this, and then the output file should be named in the same as the C file but with the extension of .0. Okay, let's try to understand. Let me clear this first. Now let me clear this and then list my content. We have this stands for assembly language. I've explained that before. This very one and this one are the same thing, and this is the file I'm working with. So if you want to create an object code, that's .0 simply means object code. You're not supposed to link to any other extension. So what you simply do is GCC -c, that will compile but will not link, and then you give the file name .c, enter. If I list again, you're going to see the file .o. This is actually an object code to this C program. That's what you are asked or told to do right here. Okay, the next one here is assembler. All right, you're asked to generate an assembly code. I think I've done that before when we were working on the first on the assembler, and that's the .s above. We've done that before. Then let's go to the next one. Write a script that compiles a C file and creates an executable named C is fun. We've actually treated that before now. You know, when I compile my file, I now give it an output name of hello. So you're supposed to do the same thing, just that your own will bear the name C is fun, and then your file, and then your C file is going to be found on this C file variable given right here. Okay, so just change my F program or first program.c to this man, and then your S file, the output is going to be given as C is fun. Okay, number 4 here says write a program that prints exactly this, followed by a new line. You are told to use the put function and not the printf. Okay, so I think we've done that before now. It's very simple, but the only difference here is this quotation mark that is added here. Let's try to see what that means. Now let's Emacs into the same program I've been using before now. So now let's say that I want to write something. Let's say I want to write my name is Engentech So I'm gonna say puts. Okay, that's what you're told to use. Now, if I write something like this, my name is Engine Tech. Okay. Now you can see that it's flagging error already because of this. Okay, you cannot use two double quotes at the same time. No, because the computer or the compiler will interpret it wrongly. So what you're supposed to do is to use your escape sequence. We treated that when we were working with shell basic the other time. So you need to put your / to actually tell the compiler that the next character ignore its specialty. So we close this and then we can save this and exit, compile. Okay, so if we run this, we can see my name is Engine Tech with that quotation mark right there. So that answers what you're supposed to do there. The next one here says hello printf. Write a C program that prints exactly this using a printf function, and then your program should return 0. We have treated this ahead of now, so you know what to do. Now they stated here that your program should compile without warning using the -wall GCC option. Okay, now this is still the same thing as using the GCC to compile your file. Let me just copy this. So if you copy this, this is actually the file name. So if I take this here to my terminal and then paste right here, okay, and then add my file name .c, it's still gonna compile. So this and this is approximately the same thing. It's just that LX uses this very one to compile your code, hence to check in-depthly for errors. All right. Now, before we go deeper, there's something I want to bring forward to your notice, because I'm sure your code number 4 will not check if you didn't do that. Now, there's what we call Betty documentation style. Your code must follow some kind of certain rules according to Betty. If you don't follow that rule, those documentations according to Betty, it's not gonna pass Betty's test. Hence, your code will not check. Now, let me open this file, and for description purpose. Now, when you're writing your code on C, you're supposed to describe the work of your function and the return value. Those two things are very, very important, except when you go to struct, you still need to define the context of struct. But for now, since you're working with just a fundamental understanding of C language, you have to define what this very parameter, what this function mean, the main function. So what you simply do is to write it as a comment, and this is how Betty comments look like. First, the slash, and then the 2 asterisk, enter, another asterisk. Then you define whatever name is found here must be defined. Then, okay, let's call this entry level. You can write anything you like, so if I describe what you feel is right to be described. Entry level. And then you can leave this to be empty. The next thing here is to describe your return function. So I'll say return return 0 if successful, or 1 if failed. Okay, so that's how you document your program according to Betty style. But the second thing here is Betty also checks for indentations. When I'm talking about an indentation, I'm talking about the space, the tab space between the margin and where your character actually, or your program actually starts from in the main. But if you probably don't have the understanding of how to align your indentations, allow everything to be on the first level. Let everything be on the first line. Don't shift anything if you don't know how to use it. But if you know how to use it, I think this is the best way, or the best way to go about it. Okay. And the second thing here that Betty normally checks is what you call trailing white spaces. Yeah, trailing white spaces. For instance, if after writing my documentations and then I put one space bar and then go down, you can see this red indicator. Your own will not be indicated because there are some codes behind this Emacs Windows environment or Emacs environment that enables me to that checkmates the white trailing spaces. But in your case, I don't think you have the code for now. So if you don't have it, don't avoid this. Ensure that you don't use your spacebar key. Don't use your spacebar to avoid that misconception, because if you do, you will not pass Betty check. Okay. So we can now save this and then compile again. Right, .c and then -o. Okay, and then hello. All right. Okay, that was this very one. So let's go to 5. Hello, print this. I think I've explained this before. Yes, I'm done with that. Number 6 says write a C program that prints the size of various types of the computer it is compiled and run on. You should produce the exact same output as in the example below. Now look at the example right here. When you run your program, it's supposed to print size of char is this, size of integer is this, long, and the rest of them. Now take note of one thing, that where you have the char, integer, long, long integer, and float, they are all data types. Now you're expected to print the byte at which each data byte occupies. Sorry, at which each data type occupies in your memory. Now this is what I mean. I'm going to show you example. Let's Emacs into that same program again. Okay, now I'm going to check for just 3 data types for illustrative purpose. So I'm going to check first for integer, A. That's just a variable name assigned to it. I'm going to check for character. Let's call that one B. I'm going to check for floats. And then let's call that one C. Okay. Now you can see that white trailing space. So don't try to do this. Avoid it. If you must skip space, take your cursor to the beginning of this character, the next line, and then hit enter. You'll not be affected with that white trailing spaces. Okay. So before this, I want to print those values, the sizes it represents. So I'm going to say print if. Okay. Now the size of int is, then I'm gonna pass my format specifier. It's gonna be a %lu, that's long unsigned long integer bytes. Okay, and then after now I'm gonna have my new line, then end of the string, then comma. Now when you're doing something like this is what happens. The size of int is colon will be printed on the screen, but whenever the format specifier is introduced, it will look for the variable that stores equivalent format specifier and then prints the value here. All right. So if I have unsigned long, all right, and then size, I'm trying to print the size of a, which represents the integer. Okay, ensure that the bracket you open is equal to the bracket you close. Now what this simply means is that when it's trying to run the program, it will first print the size of the integer. Immediately it sees this percentage sign, it will now look at the format specifier, which is lu, and then we'll take the variable name, which is a. Of course, we are printing size of, so that is a value. That's going to be a number that represents the memory byte, which integer occupies on the memory. So it will try to print that number where it sees the format specifier, such that you have something like, let's say the integer is 4 bytes. So it's going to be the size of integer is the 4 from here, which is captured or taken from here, will now be printed where you have the format specifier. So you have the size of integer is 4 bytes. I hope you understand that. Don't worry, when it's printed, you will relate it properly to get yourself clarified. Print f again. That's for the second one. You can copy and paste. The size of this time around is char is same %lu. and then bytes. Of course, my new line, unsigned long, size of this time around is B. Okay, then printf again. The size of this time around is float, is percentage %lu, bytes or bytes, n, unsigned long, size of C. You may not really need to use the unsigned long, but just for that's all. So let's run the program and see what happens. Let's compile. So C, hello. Okay, let's see. All right. Now you can see we have the size of int is 4 bytes. The 4 is where we have the LU. The size of char is 1 byte. The size of float is also 4 bytes. So let's read that unsigned long and see what happens if it's gonna work or if it's not gonna work. So we have emax this.c. So let's take this off. All right, and then let's compile that and see. gcc first.c minus o hello. Okay, so that's fine, and then hello. So it's still the same thing. You can choose to use the unsigned int. It's just to cast the variable to unsigned value instead of it to be signed. All right, so that is just that about that very task. And then the next one here is, I think that's the last one. Okay, second to the last. Write a script that generates the assembly code of a C code and save its output, and save it in an output file. The C file will be named or saved in the C file variable name. I think it's just the .s extension. We've done that before now, so I think you can solve that out yourself. Then the last one here says write a program that print exactly this statement followed by a new line, but the condition is you're not allowed to use printf and you're not allowed to use puts, and yet you're supposed to return the value 1. Okay, now look at this, followed by a new line to the standard error. This is actually an advanced task. I'm not supposed to do this, but since I am here already, the last one, let me just do it for posterity's sake. All right, let's clear this. Apart from using the puts and the print, another very important command you can use to write to the standard output is write. Just like the name implies, write. You can use this to write to the what? Standard output. Okay, so let's see how to apply that. I'm gonna use the same file .c. Now before you use write is actually not written in the library of standard input and output, but rather that is found on the include universal standard .h. That's where the write command can be found. If you don't include that, then it's not going to work for you. All right, so let me take it down out before the return 0 and then write it here. So I'm going to say write. Oh, okay, now after write, the first thing, write takes 3 parameters or 3 arguments. The first thing that you want to write in the write command is a value that indicates if you are writing to the standard output or you're writing to the standard error. When you use 1 means I am writing whatever I want to write to the standard output. But if you use 2 means you want to write it to the standard error. Now, what is standard error? Let's take, for instance, when you want to open a file in your normal computer system, let's leave programming for now, and then probably the file you want to open has been deleted. You will see a kind of error or warning that the file you tried to open does not exist, or it's deleted or something, or probably you want to run a program on your computer system or anything at all, and then the program sends you an error warning that this thing you are doing is not valid or something like that. Okay, wrong password, that's error. Okay, so those kind of messages are stored in the standard error output. Okay, so when you say 2 like this, you're trying to write to the what standard error, but when I say 1, I'm writing to the standard output. In this case, I want to write to the standard output. I'm sure you know what to do to write to the standard error according to the question given. All right, so after that, the second thing is actually what you want to write. Let's say I want to write engine tech, all right, /n. Okay, and then the next thing here is the number of bytes or character in the buffer. And in this case, you want to count here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 plus the /n becomes 10. Okay, that's just how you can execute that program. Then of course you will return 1 at the end of the day. So let's save that and see what happens. Let's compile again. a.c -o hello. Then we run the hello command. Now you can see here we have engine tech at the end of it. That's where I have my write command. Okay, but what if I didn't count the number of the size of buffer I have? Maybe I put something like 5. What do you think will happen? Let's try to see that. Maybe here okay, maybe right here, instead of writing 10, I wrote something like 5 as an oversight. Okay, so let's run the program and see what happens. gcc and then the file name -o hello. Okay, and then let's run that. Hello. You can see that you have only engine. Some of the content, some of the letters or characters had been cut off because it's gonna take just the first 5 characters. Okay, so the question is, what if I don't know what's gonna be passed? Let's say I'm gonna pass something like 100 kind of characters or 1000 characters, and I don't know how many characters I'm gonna pass actually. That is when looping or a string length comes to play. There is a function called string length. Don't worry, as you progress in the program, a lot will be exposed to you. But now I think we've come to the end of this very introduction to C, though it was a kind of so in depth. I'm sorry about that. My next video I will try as much as I can to relax, talk calmly, and then try to take it slow. Get yourself buckled up because we're going to do something very cool, all right, in this channel. Thank you very much for having me around. See you in my next video. Bye-bye.